This video is to try to help you to remember logarithmic properties. Okay, let's try to remember the definition of log. It's closely related with exponential forms. Let's see, if I have 10 square, that equals to 100. And I can write this one as a log. So how would I write it? Base 10 here, so still a base in my log. So log base 10. Then I write this 100 as the value here. So we read this as log base 10 of 100. And what does this equal to? This equals to the exponent of 10, which is 2. So whenever we see log, that means the exponent of the base. Or what's the base in 1? By default, if we don't write base there, that's base 10. So all these logs on this page are log base 10. Right. So it's the exponent. Log is it's the exponent of the base. So this whole thing, 1, is the exponent of 10. Just like exponential in exponential forms, right? If we have 10 squared times 10 raised by 3, we have same base, we can combine the exponents. So we get a 10, so we add 2 with the 3. We get a 10 raised by 5. So there are properties for exponents. So will be extended to be the properties of a log, but in different forms. So we'll see in what kind of different forms. Let me clear this. Okay, let's try 1. So let's understand this log. So first, the base is 10. And the value here is 6 multiplied by 11. So I have a product. I have a product inside the parentheses. So 6 times 11. If I read this, I read as log of 6 times 11. So I don't have to see 10. When I do not see 10, that means the base is 10 by default. So with logarithmic, I can split this into 2 logs. I can split it into a sum of 2 logs. Because this is a product. So I can write the first one as log base 10. I don't have to write it. I don't have to write the 10. So this is log 6 plus log 11. All right. So what is the meaning of this? The meaning of this is exponent of base 10. This is exponent of 10. Right. So by property of logs, we can split the product of in the value into 2 logs. So similarly for 2. So for 2, I can split into 2 logs because it's a product. I can write as log 5 plus log 3. You're right. It's that simple. Now let's see 3. 3, we have a quotient, right? We have fraction inside of 6 over 11. Then this value raised by 5. So the log property is saying if the value raised by the power exponent, we can put this exponent in front of log. So first, I write a 5 times log of 6 over 11, a fraction. Right. So I pose exponent of 6 over 11 to the front of log. And second, I see this is a quotient, right? Remember what is 6 over 11? I can rewrite this as 6 times 11 raised by -1. Right? Remember, x raised by -1 equals 1 over x. So this 11 in the denominator is 1 over 11, right? I can write as 11 raised by 1. So if I do that, I get a subtraction. So if it's a quotient in the value, I write as the numerator is positive. The denominator is negative. So denominator is minus log of 11. Right? You can go with a plus negative, right? Plus -1, plus -1, which is just minus, right? So to remember this, if it's a quotient in the value, it's a subtraction of 2 logs. If it's a product, it's an addition of 2 logs. If the value has an exponent, we pull the exponent up front the log. So let's see this one. Number 4. First, we see product, right? Then we want to split into the 2 logs. So we have log 3. I'm going to change the red color, more obvious. Plus 3 log 2, right? Because 2 has exponent. 2 has exponent 3. So when I do log, I have log 2 raised by 3. Then the exponent 3 of 2 moved in front of the log. So 4 is log 3 plus 3 log 2. Okay, I have to clear this and stop sharing, and then go to next one. Okay, let's practice more. Maybe you can do faster than me now. First, I see quotient, right? I split it into, then 2 raised by 4. So I'm going to pull this 4 up front. So I have 4 log 2. Then 5 is in the denominator. I'm going to write a negative log 5. Okay, let's see 6. 6, first I see the exponent. I'm going to move the exponent first. Right? You see this exponent is applied to 6 over 5. You see this exponent 4 in 5 only apply to 2. So be careful with this difference. So I have 6 parentheses log 6 minus log 5. Because 5 is in the denominator with parentheses. Let's see 7. 7, I have a log x. X in the numerator, positive. Y to the 6 in the denominator, and the y is raised by 6. So I can pull 6 up front of the log. This is a y. So I have log x minus 6 times log y. Let's see number 8. Number 8, this square applies to the product. So both for A and B. So I can pull up front, just like 6. So I have 2 parentheses, because I'm going to split log A times B to be log A plus log B. So 3 properties we have been using here. First property is, if it's a product, if it's like A times B, 1 log of a product, we can split into 2 logs and with addition. If it's a quotient, if it's division 6 divided by 5, if it's a quotient or division, we can also split it into 2 logs, but with a minus, with the numerator to be positive, but denominator to be negative. And if the value being raised by a power, we can put the power in front of log. Let's keep moving. Okay, so this we have a little bit more. So first I see quotient, right? So I'm going to split log u to the fourth minus log v. But the 4 is the exponent of u. So I'm going to put 4, pull the 4 up front. And sometimes we want to force the variables. If we're dealing with the variables, we want to force it to be positive. So we put an absolute value sign around it. The minus, and this 4 has nothing to do with v, right? So this 4 is just for before the log for u. And for log v, just log v. Right? There's no 4, so we don't need parentheses for this. And log v, we don't have to use absolute value sign because log v from the beginning is itself. But u is being raised by even number. If a negative number is raised by an even number, it becomes positive. So we want to force this u to be positive. Let's say 10. Log of the exponent is x. Subtract, now this 5 is only with y, is the exponent of y. So subtraction 5 log y. Right? Y was the exponent of y. 5 is the exponent of y. Now can be put up front. So we get log x minus 5 log y. Let's see 11. Cubic root. Cubic root can be rewritten as the whole thing raised by 1/3. Right? We use rational exponents to represent the radicals. So then I see product x times y times z. I see product. But this 1/3 applies to x, applies to y, applies to z. So I can pull up front. So I will get 1/3. And this one, I'm going to get 3 logs, right? Because I have 3 members in the product. First, I'm getting x log. I'm sorry, I have to write a log first. Log x. And also we want to, because it's x times y times z, we want to force all of them to be positive. Because they are variables. Maybe x is negative value, y is negative value, the negative times negative become positive. So then product indicates addition of logs. So I have 1/3 with parentheses, log absolute value of x, log absolute value of y, plus log absolute value of z. Then close parentheses. So 1/3 applies to 3 logs because 1/3 is exponent for x, for y, and for z. By the way, if you have any questions, leave comments. Leave comments. I'll see. Right. Okay, 12. So I have product, but z has exponent of 2. So we're going to pull the 2 up from the log z. So we have first, we have log x. Again, we want to force x to be positive because x could be negative, y could be negative. When they multiply 2 negative numbers, they become positive. So once we split them, we want to force each one to be positive. Then plus 2 times log z, right? Because 2 is the exponent of z. And also we want to force z itself to be positive. You see, this 2 only applies to z. So it's only in front of the log z. Okay, let's moving forward. Now we do the opposite, right? We do the opposite. Before we split 1 log into 2 logs or 3 logs. Now we want to condense. We have two logs here. We want to condense to be a single log. Subtraction indicates division in the value. So in the single log, passive term is numerator. So log 3 is passive, so 3 is a numerator. Negative log a, negative, so that means a in the denominator. And that's it. So the two logs combined to be one log with log base 10, 3 divided by 8. Let's see 14. 14, we have this 3 in the denominator. So this 3 is 1/3, right? When the number shows up in the denominator, you can always think that's 1 over the number because it's in the denominator. And of log 6. So first we write this way, right? Remember, this log, this 1/3 comes from the exponent of 6. So we can put it back. We can put it back. We can write as log of 6 raised by 1/3. What's 6 raised by 1/3? It's cubic root of 6. Okay, so that's log cubic root of 6. Let's see 15. 15, we see 4 before log, so that's exponent of 3. We see 4 again in front, so that's exponent of 8. Subtraction indicates division in one log. So we write as log. Numerator 3 raised by 4. Denominator 8 raised by 4. Or we can write as log 3 over 8 with parentheses raised by 4. That's a single log. Okay, so two logs were combined to be a single log. Let's see 16. Passive, right? Addition of 3 logs. That means 1 log of product. 2 times 11 times 7. Let's see those ones. Have difference of 2 logs, and this 2 in front of a log goes to be the exponent of 12. So I write as log, 1 log, but it's negative, so it appears in the denominator. Log of a numerator will never see minus subtraction of 2 logs. I know that's a division in the value. 7 in the numerator, 12 squared in the denominator. Minus 2 log 12 tells you that should be in the denominator. Okay, let's see this one. This one, 2 over 3 is the coefficient of log 7 and comes from the exponent of 7. So 7 raised by 2 over 3. Well, let's write the first step. Log 7 raised by 2 over 3, rational exponent. We want to write back as a radical form. So we write as log. So the radicand is 7. The index is the denominator, 3. And the numerator is the power. So 7 squared is 49. So we get log cubic root of 49. For 19, 6 goes to be the exponent of u. This 6 is going to be the exponent of v, right? And we want to do single log. So we combine sum as a product. It's log of u v both raised by 6. I'm sorry. Right, u times v both raised by 6. Because 6 is exponent of u, 6 also exponent of v. So we can write like this, log of uv raised by 6. Subtraction again, so this one can be written as ln x divided by 4y raised by 4. That's it. Okay, let's finish this too. 4. We see 21 is very similar, right? Very similar. We have a 6 goes to the exponent of v, and then this is subtraction means division. So we write it as 1 log base 4. Right, this one is base 3. Log can be any base, any counting number. So the first one is u, the numerator is u, and the denominator is v raised by 6. 32. So this 5 goes to be the exponent of v. So we write as 1 single log. We still have base 3, right? Those 2 logs still have the same base 3. U is in the numerator, and the v to the 5th power in the denominator. Let's see 23. 20 is the exponent of u. 51 is the exponent of v. They're all under base 6. So we write that as log base 6 for u raised by 2001. U raised by 2001 multiplied by v raised by 5. So single log is log base 6 u to the 201 multiplied by v to the 5th power. Now let's see 24. 4 goes back to be the exponent of u. 20 goes back to be the exponent of v. Log base 3 doesn't change. So we write as a single log, log base 3. Then u to the 4th power in the numerator divided by, well, this divided by 20, no, v to the 20th power. Oops, sorry, lost my pen. V to the 20th power. Okay, hopefully this helps. I'm going to keep talking more, but not now.